how to do the queue operation, and we learn about the array-based queue. So in the array-based queue, we know about the normal configuration. The normal configuration means whenever we remove one item in the front, then the front will change, so the variable f will change according to the index number. Okay? And then we can have the wrap around configuration. The wrap around configuration means the index of f and r will be wrapped according to the size of this array, because we cannot have the bigger size, so we can just utilize the existing size of the queue, or the queue. Yeah, this is the queue, means the queue data structure. And then yeah, we will always update the index of f and r. And we already learned how to use the modulo operator to figure out about the n, f, and r. And with this kind of formula, so we want to get the size. So the size will be the n minus f plus r modulo n. And then if it is empty, then it means f equal to r. And we already learned how to deal with the r. Okay, so if we are doing NQ, okay, what does it mean by NQ? NQ means, yeah, we want to put one object in the queue. Okay. So in this case, if this queue still empty, yeah, you can do the rotation or the wrap around configuration. Okay. So when the size is n minus 1, then it will go to exception. Okay. But if it is not full, then you can update the rear r. Okay. R is the rear one. So you will update the r, and you can just put the object O in the index r. And then r will be updated with r plus 1 modus n. So in this case, whenever you have no empty space in your queue, you will go to throw exception. You will go to this exception. You will not be able to add more objects. And the same with the DQ. Yeah. Whenever it is empty, you will go to the exception. And then, yeah, if it is empty, you will go to exception. If it is not empty, you will get the front. Okay, so the front will be in the object O, and then the front will be updated, because whenever we get, or whenever we remove one object, then the F will be empty. So we need to go one more, or plus 1 from the original F. Okay. So the queue in Python, we can have 3 data, which is the data to know about the capacity, and then the size. This is to know about the size of the queue, and the front. Okay, front is the first element of the queue. I think we already learned about the queue before. Okay, I will review a little bit about the queue. And one of the application of the queue is the round robin schedulers. Yeah. So in the round robin schedulers, we want to apply the circular queue. Okay. So the circular queue is the same with the queue, but we will not enlarge the size of the queue. Instead of enlarging the size of the queue, we will always just use the queue. Okay. So the queue is having dq. It means we will remove the first element, and then it goes to the share service, and then after we finish with the share service, it will go back to the queue or NQ. So this is the round robin scheduler. So whenever we finish the service, it will return back to the queue. So the method will consist only two, the queue and NQ. So let's see on the code. So last time we have the queue. Yeah, we have the function dq. Okay. So in the function dq, yeah, we will give, if it is empty, then we will go to the exception. Yeah, in this case, I didn't use the race exception, but just print the queue is empty. If it is not empty, so it means I want to remove one. I want to remove the front. After I remove the front, okay, so here, let's make the data in the front becomes none. And then I will add by 1 and then modulo the length. After I have this new front, then the size will be reduced by 1. Different with the NQ, yeah, we will do the additional plus by 1 for the size. But before that one, okay, can you see the difference between the PowerPoint and this code? For the NQ, okay, for the NQ in the PowerPoint, in the NQ in the PowerPoint, when you reach the size, then you will throw the exception. You will give this exception message. So you cannot have more objects. You cannot have additional objects in your queue. However, in the code, yeah, what is this one? If the size equal to the data. So it means if the array size already equals to the capacity, now we can resize. And how to resize this one? We use the method resize, and then the capacity will be double. If we want to have the array enlarged, so we have two strategy. Last time we have the incremental and then double strategy. So we have this strategy, double the array strategy. Yeah, it depends on what you are going to do. So if you are using the full queue exception, means you will not enlarge the size. If you want to enlarge the size with the doubling strategy, then this will be the case. So the resize will be here. Yeah, I will explain a little bit later. So the same with the previous one, the front will be updated. So the NQ, this is the front plus size modulo length. So the formula here will be the same with this one. Oh, sorry, this one. Okay. Oh, so this is NQ. This is NQ means the front plus the size modulo the data. So we want to put the object E into the available section. Okay. So the idea is the same with the rear one. So rear means front plus size. Okay, so if we have, for example, if now we have the F is 4 and the R is 14, okay, and we know that the size is 17. Okay, so it means, yeah, we can have the front plus size, yeah, 4 plus 17, and then we will mod with the n. So that will be the same with this formula. So we do not need to define the rear variable. So the resize is the way to increase the capacity. Okay. So the capacity here, yeah, it depends on your strategy. If your strategy is incremental, then you will add the size by 1. Or if you have the double strategy, then means you will add the size with 2 of the capacity. So the same with the problems we learn from the array. So every time we want to resize, the old data will be saved, and then we will enlarge the capacity. So we need to prepare known, multiply the new capacity, and then walk. Walk means we want to change for every element from the old queue. So here, for every element k in the old, it will be assigned into the old walk, and then the walk will be updated according to the information from the old data. And after we have all the things, we will assign the front equals to 0. So it will be realigned. Okay. So when you run this code, yeah, when you run this code, yeah, you will see the result. The same with the example that I put on the PowerPoint. So we have the array queue. Okay. When we enqueue, it means we put one object into the this queue, and then enqueue again, we put one more object into the queue, and then we will have the length equals to 2. And then if we dequeue, then means we will remove. And then it's empty, yeah, because we still have the element, then it is false. And then if we dequeue, it means we want to remove again. And then it's empty because we already 2 times dequeue, then it is true. And then if we dequeue again, then it will be errors. So the enqueue, we have one more object entering the queue. We have the second object entering the queue. And then if we want to check the first, then the value will be 7. And then we entering a new object 4. So the length will be 3. And then the last one, if we remove this one, then yeah, 7 will be removed from the queue. So the data will be something like this one. So this is the front, then this is the new front, and this is the new rear. Okay. Until we finish with all this statement. Okay. So the circular queue, yeah, we already learned about the circular queue. So this circular queue is using the idea of the queue, okay? But it will use one of the problem about the linked list. Yeah? So I will explain this code in after the mid exam, I guess, okay, because it is related with one of the data structure, which is linked list. Okay, so I guess, yeah, your mid exam will be until this queue. Okay, so you will utilize the stack and you will utilize the queue for some problems in your mid exam. And how will you understand about the code here? Yeah, it will be one or two of the problems in your mid exam. Okay. Okay, any questions? So we learned already about the basic concept of queue, and then we already learned about the array-based queue and some application about this queue. Okay, I thought that I will explain this one after the mid exam, but because we still have some time, let me explain only the concept about the linked list. So linked list is one of the data structure in the data structure, and we are going to learn what is this concept. If we take a look on this figure, it seems that, yeah, it is the same with list, or it's the same with the array, and etc. So the idea of the singly linked list is a kind of data structure to understand the sequence. So the sequence means it is a kind of sequence like, yeah, in a list or tuple, or yeah, any data structure that you understand like stack, queue. Okay, but yeah, we have one thing here which is head. So the head, it is the beginning of the list. Okay? And every of these element should have the head. Every of the element should have the head. Every of the element should have the head. And this element, okay, will have link to the next node. So we call this is like, this is the element. Okay, this is the element, and then there will be a link to the next element. This will be the element, and there will be a link to the next element. So if you are doing the routing sequence, so for example, after I go from the school, okay, from the Hanguk, we want to go to the, for example, there is the bus terminal Mohyun, bus terminal in the Mohyun Sagori, okay, and then after the Mohyun Sagori, you go to another bus stop, and then you go to another bus stop, okay. So it can be one of the singly linked lists because it is a sequence, routing sequence. We can use operation in the delete and undo. So if you know in the notepad memo junk. Okay. So if you type, for example, here I will use this notepad. So let's say if I type something, half, yeah, and then if I delete, and then if I want to undo, so I can just press Ctrl Z. They still save what I deleted just now. Okay. And then, yeah, they can easily retrieve. Okay. So for example, this is how, what is the undo? Okay, so like this one, then you can easily get what you already deleted because they save what was the previous sequence. Okay. So we can use that idea, and it was under the linked list or photo viewer. So if you watch a photo in your monitor, you can see what will be the next photo, what will be the next photo, or what will be the previous photo. Okay. So we can extend with the other data structure like stack, queue, and array, and we can use also list. Okay. But now the problem of the linked list should have node. Okay. That's why there is one class, we call it node. In order to have this one, we need to have two more elements or two more variables. The first is the element, and the other is the next node. So we have already the structure. This is to indicate the element, okay, and then this to connect to the other node. This is the class node, and then this is the node class to indicate what will be the object that is connected. So this one is the node. Okay. This is the constructor. If there is no element, then just null, null. But at the first, yeah, you can define what is the object and what will be the next node. So for example, if I have the data, this is 한국외대. So what is the next bus stop? If you use the bus from 한국외대 to Seoul, then you will have a connection. The next bus stop is, I don't know, maybe we can say this is the dormitory. Okay, half dormitory. So there is a connection or there is a link from the half terminal, 한국외대 terminal to half dorm. And then there will be another link to another node. So the element means what is the current information, and the next is the next node. If we want to get the element, yeah, we can just object get element. If we want to get the next, we can just get the next. If we want to set the new element, yeah, we can do the set element. If we want to set the next node, then we can also use this method. So whenever we use this linked list, actually we want to allocate a new node. So for example, this is a trip. So you have a trip from Rome to Seattle to Toronto. So this is the head, or we can say this is the starting point. And it will be connected to another node. This is another city, Seattle, and then this is another city, Toronto. And then because we have nothing, so we just keep empty. If you want to insert a new element, Okay. So the new element will be in the head. Okay. So the Baltimore, for example, it will be inserted. So the position of the head will be removed and it will change to the first element. So we need to update the head to point to the new node. So every time we want to insert, if we use this kind of linked list, then it will be in the head. So if we want to remove the head, it means we have the head Baltimore, okay, and then we want to remove this Baltimore. So it means the node will be deleted and the pointer head should be modified to the other node or the next node. And so the next node will be room. So yeah, that's the sequence to understand. And the pointer head should be available for this linked list. And we have what we call as tail. Okay. So tail means we want to have the last element. In the last element, in this case, if you can see the visualization, Toronto is the last element. And let's say I want to add one more element at the last. After I go to Toronto, I would like to visit Zurich. Then, I will add this node here. And after I connect this node Zurich with Toronto, I need to update the tail. Okay, I need to update this pointer. And if you want to remove the tail, okay, so in this case, in the singly linked list, okay, in the singly linked list, we call it this is not efficient, okay, because whenever we want to remove, we need to remove the head first. Then the head will be shifted to the next node, and then it will be shifted to the next node, okay, until the last one. So if we use the removing at the tail, we need to remove from the head until the tail. So we need to remove from the beginning until the end. That's the weakness of the singly linked list. So there is no constant time way to update the tail to point to the previous node. So that's why the idea of the linked list can be combined. If you combine with the stack, we can say this is stack as a linked list. So whenever we have a new element, we can use stack. Whenever we have a new element, then we can use stack. So the stack, we know that it is the L, I, F, O. Okay. Last in, first out. So when we do with the last in, first out, so the top element is start at the first node. So this is the first element. It will be always the first, and this is the top element. The space will use ON because we will have 1, 2, 3, 4. There are 4 nodes, so it means always n times. And then for every its operation, it will take like O1 for inserting a new element, for removing the element. Okay, so we will take O1. So this is the linked list. stack in Python. I already put the code in your e-class. So we can use one more class, which is node. And the idea is to have the element and the next. Okay. And the other, like top, pop, push. Okay. So we apply the stack. Like is empty, length, init is the standard of the auxiliary method in stack. But push, pop. Okay. So push means we want to insert a new element. Pop means we want to remove the element. And then the top, we want to know what is the current position in the top of the stack. We can implement also with queue. Okay. So the linked list we can also implement with queue. If we implement with queue means we will define the front element as the first node, and we will define the rear element as the last node. Okay. So the space will consume on because every node will have one position. So it means the n data, we will need n space. And for every operation, so this operation means insertion and insert and delete. Okay, so it will take O1. And this is the linked list with queue. If you have the stack, there are two methods, which is pop and push. But in the queue, we have dequeue and enqueue. The only difference is now we implement with node. So we need to have one node, and then for every element we inserted, for every element that we remove, it will connect with the whether it is the next element or not. Okay, I guess that's about the linked list. I think I don't have much time to explain the code. Okay, so let's just finish until this part, and your exam will be until the queue. Okay. Your exam until the queue. So I will continue about the doubly linked list next week on Monday. As I mentioned to you, let's have class on April 26th because we have 2 holidays. Okay, so I hope that we can cover all the contents when we have this holiday and week 15. Okay, any questions?